Hey folks, and welcome to Unit 4, which is called Linear Momentum. This first set of videos is going to be on defining momentum and talking about how momentum changes and what we call that. So I'll get us started. We're just going to define linear momentum here. Now, because I'm calling it linear momentum and not just momentum, that means that there's another type of momentum we'll learn later called angular momentum. So I will probably slip up a lot of times and just refer to this as momentum. Because angular momentum is an extension of this. So, sorry. Okay, linear momentum has the variable of lowercase p, and it is defined as a system's mass times its velocity. So, momentum is defined by an equation. It is very poorly defined by words. And so, the most common thing you would see in a textbook would be the amount of motion. Doesn't mean a heck of a lot, but it does you can kind of paint a picture. Like if you have a very massive object that is moving slowly, it can have a similar amount of motion as a very light object that's moving very quickly. The definition that I like better, that is very unofficial, is that momentum can be thought of as, if this thing hits me, how much would it hurt? Because again, the velocity of an object does influence how hard it will hit you, but the mass of an object also influences that. So if you throw a ping pong ball and a baseball and both of them hit you, you will get hurt more likely by the baseball because it's more massive, even though it's moving at the same speed. Anyway, it's a product of mass and velocity. A pretty common question in all of these mechanics units after Newton's second law is like, why are we defining other things if we already have Newton's second law? And the answer is conservation laws. We defined kinetic and potential energy because in nature we found that those values can add up to a constant number under a lot of circumstances, and momentum is the same thing. Anyway, let's move on. Because of the symbol, you know that momentum is a vector. And so I just want to remind you that direction is incredibly important. And you've just finished a unit where you were only thinking about scalars for the most part. And it's not that it was easy, but it was very different from when you worked with forces and projectile motion. So now that we're back in the world of vectors full time, you want to pay close attention to what direction things are moving in. If I have a 5-kilogram object and it's moving to the right at 2 meters per second, that is different from a 5-kilogram object that is moving to the left at 2 meters per second. In our frame of reference, one of these has to have a momentum of positive 10, and the other one has to have a momentum of negative 10, and those are different. More on vectors, because momentum depends on velocity. The direction of the velocity is also the direction of the momentum. So if the momentum is directed to the east, the object has to be moving to the east because its velocity has to also point to east. Really, the last thing about momentum is the unit. The unit is for now nothing special. So it's mass times velocity. So it's the unit for mass times the unit for velocity. So kilogram meters per second. This unit is in the process of being named because so many other units in mechanics are named after people. This unit will probably be renamed like this year or next year. Anyway, okay, so that's what momentum is. It can point in any direction, and it's equal to mass times velocity. Positive and negative momentum values are normal. The plural of momentum is momenta. I don't like saying that, but I will probably say it from time to time. Okay, the last thing I want to leave you with in this video is a momentum that is in 2 different dimensions. We set up a frame of reference every time that has like a positive x and positive y axis. If we do that, but the momentum value points at a different direction, that's momentum p, and that's 30 degrees. then we have to just keep in mind that we are experienced with working with vectors in 2 dimension. You don't do this a lot with momentum in this course, but it will come up. This object has both an x and a y component of momentum. And so if it's 30 degrees north of east, it would point in that direction, which means it has an east component and a north component. And so your like trig for right triangles applies again. The x component of this object's momentum is going to be 40 times the cosine of 30 degrees. And the y component of its momentum is going to be 40 times the sine of 30 degrees. And so you are expected to know how to work with momentum in 2 directions, even though you're probably not going to need to solve any computational problems. It's important to note that. That's it for the first video.